What if Earth's inner layers were not just molten rock and pressure, but something more, alive? Imagine the planet's deep mantle pulsing like a heart, slowly orchestrating the birth of a new ocean while splitting an entire continent in two. This isn't science fiction. It's the groundbreaking revelation emerging from East Africa, where geologists are witnessing the Earth's geological heartbeat in action. But here's where it gets controversial. Is this process a gradual, inevitable shift, or could it accelerate into something catastrophic? Let's dive into the details. Deep within our planet, the mantle, a thick layer of semi-molten rock, experiences immense heat and pressure. This heat doesn't sit still. It surges upward in slow, rhythmic movements called mantle upwellings. These upwellings are key players in shaping Earth's surface, fueling volcanoes, breaking apart continents, and even birthing new oceans. Now, a team of researchers from the University of Southampton and Swansea University has uncovered a startling truth about one such upwelling beneath the Afar Depression in East Africa. The Afar region is no ordinary place. It's a geological hotspot where three tectonic plates, the main Ethiopian rift, the Red Sea rift, and the Gulf of Aden rift, collide and pull apart. This triple junction is one of the few spots on Earth where we can witness continental rifting in real time. Scientists have long suspected a massive mantle plume was at work here, but the new study paints the clearest picture yet of its structure. Using lava samples from over 130 young volcanoes, the team discovered that the mantle beneath Afar isn't a uniform steady flow. Instead, it's a chaotic patchwork of plumes and hotspots, each with distinct chemical signatures. Lead author Emma Watts likens this to a cardiovascular rhythm, a pulsing, uneven heartbeat that varies in strength and direction. These pulses of molten rock are channeled by the stretching plates above, Watts explains. The thinner the crust becomes, the easier it is for the mantle to rise, accelerating the rifting process. But here's the twist. The speed and intensity of these pulses depend on the movement of the plates above. In fast-spreading zones like the Red Sea rift, the mantle surges upward in focused, powerful bursts. In slower regions, the flow spreads out more gradually. This dynamic interplay between the deep Earth and surface tectonics is rewriting how scientists understand continental breakup. Co-author Tom Gernon, a professor at Southampton, emphasizes the implications. The chemical patterns we see suggest the plume is actively pulsing, like a heartbeat. And this rhythm isn't random. It's influenced by how fast the plates are pulling apart. This connection between deep mantle flow and surface activity is a game-changer. The upwelling isn't just a passive force. It's a responsive one, shaped by the very tectonic plates it helps to tear apart. The results are staggering. In some areas, the Earth's rigid outer shell, the lithosphere, is thinning to as little as 15 kilometers. Combined with the stretching of the crust, this thinning triggers volcanic eruptions and seismic swarms. Lava flows already blanket Ethiopia, and the Horn of Africa is inching closer to a full-scale split. Eventually, seawater will flood in, carving a new ocean basin, a slow-motion replay of how the Atlantic Ocean was born. Yet, this discovery isn't just about Africa's future. Mantle plumes like the one in Afar could explain ancient volcanic eruptions and environmental upheavals. For instance, the North Atlantic Igneous Province, responsible for Northern Ireland's Giant's Causeway, may have spewed enough CO2 and sulfur dioxide to alter global climate. Could similar processes be responsible for mass extinctions in Earth's history? The study, published in Nature Geoscience, opens new doors for research. Scientists now plan to map how mantle flow directs volcanic vents and how thin plates influence these dynamics. Without collaboration across disciplines and institutions, Watts concludes, we'd be piecing together a puzzle with missing pieces. Only by combining chemistry, tectonics, and geophysics can we see the full picture. So, what does this mean for us? The Earth's mantle isn't just a distant, inert layer. It's a dynamic force actively shaping our planet's surface. And in East Africa, we're watching history in the making, a continent slowly splitting apart, guided by the pulse of a deep geological heartbeat. But here's the question we can't ignore. If mantle plumes can create new oceans, could they also trigger disasters we're not prepared for? Share your thoughts. Do you think these deep Earth processes are a marvel or a warning?